Hello, good morning everyone. Today I am here to make you understand about the phase diagram. So in the last lecture we had talked about the type of the phase diagram in which we talked about binary phase diagram, ternary and quaternary phase diagram. The basic definition of these phase diagrams were discussed. But we missed one phase diagram, that was unary phase diagram. So we have tried to incorporate the unary phase diagram on the whiteboard. You can see we have drawn unary phase diagram. But before that, before delving into the unary phase diagrams, we will try to understand what are the externally controllable parameters. Means the parameter which can be controlled externally controllable parameters. These are three parameters: temperature, pressure and composition. So out of these three parameters we will keep one parameter constant and other two parameter will be getting varied, and by varying the two parameters phase diagram will be plotted, and in that phase diagram we will try to understand the transformation of the phase diagram and how microstructures are developed. So all these things will be discussed. So let's start with the unary phase diagram. So unary phase diagram is here, and for saving of the time we have already plotted the unary phase diagrams. In the unary phase diagrams we have kept composition of water is constant. Actually we have not kept the composition of water constant, it is already constant. We cannot change the composition of water because we already know what is water means H2 means its composition is already constant. We cannot vary, because we can vary composition in case of mixture. Suppose a homogeneous mixture, homogeneous solid solution are there, heterogeneous solid solutions are there. In those cases we can change the composition. But here water is already a pure substance here, and also it is a single phase. So the composition of water cannot be changed here. So I cannot claim that the composition of water is being held constant here. It is already constant. So try to understand, the composition of water is already constant, and we have tried to vary the temperature and pressure. And by varying the temperature and pressure, we have tried to plot phase diagrams in which you can see all the three phases are coexisting: solid, liquid, and vapor. So these are the reasons in which you can find for this pressure and temperature combinations. In this region you will find solid phase only, in this region you will find liquid phase, and in this region, in the third region, you will find vapor state. Water will be found in the vapor state in this region. And you can find one phase also, one region, one point. This is only a single point, it is not a region. This point, the point that is indicated by O, this point is a triple point. Triple point, it means a point where this is a combination of such a combination of temperature and pressure where all the three phases coexist: solid, liquid and vapor. Solid, liquid and vapor means our ice, water and vapor. So water in all the three states of matter will be coexisting at this point. So what is this point? This point is 0 degree Celsius of temperature, and the pressure is 0.01 atmospheric pressure. So at this point all the three phases will be coexisting, and we can see that these are the solid phase and these are the liquid phases. So there is a line of separating these two regions. So the line which are separating these two regions will be known as a phase boundary, because we know solid is a different phase and liquid is a different phase, and a line separating both of these phases will be known as a phase boundary. So we can see there are three phase boundary lines: OB, OC and AO. All these are three phase boundary lines where the phases are separating from each other, phase regions are separating from each other. And we should also point out that all the phase boundary line at every point of the phase boundary line, suppose this is the point, at this point solid and liquid will be coexisting together. You have also studied about the latent heat of water. What is the latent heat of water? If we start melting the ice, then you will find that first of all it will start melting, and after when the melting starts, first of all it will start taking heat. It will not nothing will happen at all. But when the temperature reaches at 0 degree Celsius, then you will observe that water is taking heat, means ice is taking heat, but the phase of the water is not changing. So it means that at constant temperature the heat is being taken taken by the molecules of water. So those temperatures are those regions are known as the latent heat, hidden heat. So those are known as hidden because it is not actually visible on the phase diagram. So you can see that this is the point where the latent heat of water is hidden. So here you can see that solid and liquid phases coexist together in the same way on the phase boundary separating liquid and vapor at each and every point of the OC line OC. Liquid and vapor will be coexisting in the same way. And the phase boundary line AO are separating solid and vapor region, and every point of the AO line will be representing a situation in which solid and vapor will be coexisting together.